After age 50, the body undergoes a fundamental shift. Hormones begin to decline, recovery slows, and muscle mass starts to decrease. This isn't just about aesthetics. This is about functionality, vitality, and independence. The ability to carry groceries, walk upstairs, or even maintain balance. These are directly linked to the integrity of your muscle tissue. But here's the problem. Most people are missing one critical nutrient that their muscles desperately need to rebuild, repair, and regenerate. That nutrient is leucine. Leucine is an essential amino acid, a building block of protein. But it's not just any building block. Leucine acts as a molecular switch that activates muscle protein synthesis. Think of it like flipping the ON button in your muscle cells, telling them it's time to grow. After age 50, the human body begins to undergo a progressive decline in muscle mass and strength, a process known as sarcopenia. This is not just a cosmetic issue. It's a fundamental biological shift that affects nearly every system in the body. Muscle tissue is not only responsible for movement, it's deeply involved in metabolic regulation, glucose uptake, insulin sensitivity, and even cognitive function through the release of myokines, which are signaling molecules secreted by muscle during contraction. As muscle mass decreases, so does functional capacity, and this decline is tightly linked to an increased risk of falls, fractures, frailty, and loss of independence in older adults. The underlying causes of this muscle loss are complex, but two major contributors stand out: hormonal changes and metabolic resistance. Around midlife, the levels of anabolic hormones, such as testosterone, growth hormone, and IGF-1 begin to decline. These hormones play a vital role in driving muscle protein synthesis and maintaining the structural integrity of muscle fibers. With lower circulating levels of these hormones, the muscle's ability to repair and regenerate is compromised, even in the presence of adequate physical activity and nutrition. Additionally, the body's muscle cells become less sensitive to dietary amino acids, a phenomenon known as anabolic resistance. In younger individuals, a relatively small amount of dietary proteins is sufficient to stimulate muscle protein synthesis. However, in older adults, the same dose of protein produces a significantly blunted response. This means that simply eating what you've always eaten is no longer enough. The body needs a stronger signal to initiate the same anabolic processes it once did with ease. Mitochondrial function also deteriorates with age, contributing further to the decline in muscle health. Mitochondria are responsible for generating ATP, the energy currency of the cell, which is essential for muscle contraction, repair, and endurance. As mitochondrial efficiency declines, fatigue sets in more easily, recovery takes longer, and training adaptations become slower and less robust. Neuromuscular junctions, which are the connections between nerve cells and muscle fibers, also degrade with time. This results in less efficient signaling from the brain to the muscles, leading to coordination issues and decreased power output. These degenerative changes at the cellular and systemic levels compound over time, making it increasingly difficult to maintain strength and lean mass without deliberate intervention. Even the inflammatory profile of the body changes after 50. Chronic, low-grade inflammation, sometimes called inflammaging, can suppress muscle protein synthesis and accelerate muscle breakdown. Elevated levels of cytokines such as IL-6 and TNF-alpha can interfere with anabolic signaling pathways, reducing the effectiveness of both exercise and protein intake in preserving lean tissue. Ultimately, these biological changes mean that muscle preservation after 50 requires more than just staying active. It demands an intentional, science-informed approach that compensates for these natural declines in hormonal function, cellular energy production, and anabolic signaling. Without that shift in strategy, muscle loss will continue unchecked, silently undermining strength, stability, and long-term health. Leucine is one of the 9 essential amino acids, meaning the body cannot produce it and must obtain it through diet. Among all amino acids, leucine holds a unique and powerful role in human physiology, particularly in muscle maintenance and growth. It acts not just as a building block of muscle protein, but as a metabolic signal that initiates the entire process of muscle protein synthesis. This makes leucine fundamentally different from other amino acids. Its presence in the bloodstream after a meal serves as a trigger for the body to begin repairing and rebuilding muscle tissue, especially after exercise or stress. The primary mechanism by which leucine activates muscle protein synthesis is through the mTOR mechanistic target of rapamycin pathway. mTOR is a central regulator of cellular growth and repair. When leucine concentrations in the blood reach a sufficient level, mTOR is activated and the machinery of protein synthesis is turned on within muscle cells. This process leads to the repair of damaged fibers and the creation of new ones, both of which are essential for maintaining muscle mass as we age. Without sufficient leucine, even if overall protein intake is adequate, this anabolic process will be suboptimal or blunted entirely. Leucine's potency in stimulating mTOR is significantly greater than that of other amino acids. Studies have demonstrated that isolated leucine supplementation can increase muscle protein synthesis to a similar extent as a complete protein meal, although the full spectrum of amino acids is still required for actual tissue building. The key insight here is that leucine doesn't just contribute structurally to new muscle tissue, it serves as the switch that turns on the entire muscle building process. This is especially important for older adults who experience a reduced sensitivity to the signaling process, a condition known as anabolic resistance. Anabolic resistance refers to the decreased efficiency with which aging muscle responds to dietary protein and resistance exercise. This phenomenon makes it more difficult for older adults to maintain or build muscle mass even when engaging in behaviors that would have been effective earlier in life. One strategy to overcome anabolic resistance is to ensure that each meal provides a sufficient dose of leucine, typically around 2.5 to 3 grams per meal for individuals over 50. This amount has been shown in clinical studies to overcome the impaired signaling and restore a more youthful muscle protein synthesis response. Dietary sources of leucine include high-quality, complete proteins such as beef, chicken, eggs, dairy products like Greek yogurt and cottage cheese, and particularly whey protein, which has one of the highest leucine contents per gram. Plant-based proteins generally contain lower amounts of leucine, meaning that individuals on vegetarian or vegan diets must consume a higher total quantity of protein to reach the same leucine threshold. Leucine supplementation, such as through branched chain amino acid, BCAA powders, or leucine-enriched protein shakes, is also a practical option, especially for those who have low appetite, digestive issues, or dietary restrictions. As the body ages, one of the most significant changes in muscle biology is a phenomenon called anabolic resistance. This refers to the reduced responsiveness of muscle tissue to stimuli that once effectively triggered growth and repair, specifically dietary protein and resistance exercise. In younger individuals, even a modest intake of high-quality protein can initiate a robust muscle protein synthesis response. However, after the age of 50, this response becomes noticeably blunted. The same meal that would have previously supported muscle recovery and growth now produces a far weaker effect at the cellular level. This is not due to a lack of physical activity or general health, but rather a shift in the molecular signaling environment within aging muscle. Aging muscle tissue shows alterations in intracellular signaling pathways, including a reduction in the sensitivity and activation of the mTOR pathway, which is essential for initiating protein synthesis. When dietary protein, particularly the amino acid leucine, is consumed, mTOR is supposed to respond rapidly and initiate the synthesis of new muscle proteins. However, in older adults, this process is dampened. The receptors and enzymes involved in recognizing and transmitting the signal from leucine to mTOR become less efficient. As a result, even if total protein intake is adequate, the signaling cascade that leads to new muscle tissue formation does not fully activate unless a higher threshold of leucine is reached. This shift in sensitivity means that older adults need to be more strategic with both the type and timing of protein intake. Simply eating protein is not enough. The quality and amino acid composition matter significantly more. Consuming larger boluses of protein that are rich in leucine helps compensate for the reduced sensitivity of aging muscle. Clinical research supports the idea that approximately 2.5 to 3 grams of leucine per meal is necessary to reach the activation threshold in older individuals, compared to roughly 1.8 to 2 grams in younger adults. This difference becomes crucial in day-to-day nutrition planning for anyone aiming to preserve muscle mass and function over time. Another contributing factor to anabolic resistance is chronic low-grade inflammation commonly seen in aging populations. Elevated levels of inflammatory cytokines such as IL-6 and TNF-alpha can interfere with anabolic signaling and reduce the efficiency of protein utilization. Additionally, insulin resistance, which becomes more prevalent with age, may also inhibit the transport of amino acids into muscle cells, further limiting the muscle's ability to respond to dietary protein. Together, these factors create a physiological environment where the muscle is less responsive and less efficient at building or maintaining itself, even when effort is applied. Resistance training still remains a critical component in overcoming anabolic resistance, but its effects are amplified when paired with precise nutritional strategies. By optimizing protein intake with a focus on leucine-rich sources and consuming them at regular intervals throughout the day, the anabolic signaling pathways can be more effectively activated. This targeted approach helps offset the age-related decline in muscle building efficiency and supports the long-term maintenance of muscle health and strength. To effectively support muscle maintenance and growth in individuals over the age of 50, one of the most important nutritional strategies is ensuring that each meal delivers an adequate dose of leucine, typically in the range of 2.5 to 3 grams. This target is based on evidence from clinical studies examining the leucine threshold required to activate the mTOR signaling pathway in older adults. Unlike younger individuals whose muscle cells respond efficiently to lower doses of leucine, aging muscle becomes less sensitive and requires a stronger stimulus to initiate protein synthesis. Without meeting this specific leucine threshold, the anabolic response to a meal may be insufficient, even if the total protein intake seems adequate. The idea of dosing leucine per meal rather than per day is critical because muscle protein synthesis is stimulated in a pulse-like fashion. This means that it's not just the total daily protein that matters, but how that protein is distributed throughout the day. Each opportunity to trigger muscle protein synthesis is tied to whether the leucine content of the meal is high enough to flip the anabolic switch. If a meal is low in leucine, it may not trigger a significant anabolic response, resulting in what is effectively a missed opportunity for muscle maintenance. Many older adults tend to consume the majority of their protein in one evening meal, while breakfast and lunch are often carbohydrate heavy and low in protein. This uneven distribution reduces the number of effective protein synthesis signals throughout the day and can lead to a gradual loss of muscle mass over time. A practical solution involves aiming for around 25 to 35 grams of high-quality protein per meal, assuming that this amount contains the necessary 2.5 to 3 grams of leucine. Animal-based proteins such as eggs, dairy, poultry, beef, and especially whey protein are particularly effective because they are not only complete proteins, but also naturally high in leucine. For example, a single scoop of whey protein isolate can provide over 2.5 grams of leucine in just 25 grams of total protein. In contrast, plant-based proteins typically contain less leucine per gram, which means that larger total quantities must be consumed to reach the same threshold. This can be challenging for individuals with smaller appetites or digestive limitations, especially when fiber content is high. Additionally, the timing of protein intake relative to resistance training can enhance the leucine response. Consuming a leucine-rich meal or shake within an hour or two of strength training takes advantage of the increased sensitivity of muscle cells following exercise. This post-exercise window is a time when muscle tissue is more receptive to amino acid uptake and protein synthesis, making it an ideal moment to ensure that leucine levels are optimized. It's also worth noting that achieving the leucine threshold at each meal does not necessarily require supplements, but for individuals with dietary restrictions or reduced appetite, using targeted supplementation such as leucine-enriched protein powders or BCAA blends can be an effective strategy. This approach ensures that even small meals can deliver the required anabolic stimulus needed for muscle preservation and growth in the context of aging physiology. Animal-based proteins are widely recognized for their superior leucine content and overall amino acid profile, making them the most effective dietary sources for stimulating muscle protein synthesis, especially in older adults. Among these, foods like beef, chicken, eggs, dairy products such as cottage cheese and Greek yogurt, and particularly whey protein, offer a highly bioavailable form of leucine that efficiently activates the mTOR signaling pathway. These proteins are complete, meaning they contain all 9 9 essential amino acids required by the human body, and they are naturally high in branched-chain amino acids, especially leucine. This combination is critical for effectively triggering muscle repair and growth, particularly in individuals experiencing anabolic resistance due to aging. Whey protein stands out as one of the most leucine-rich sources available. Just 25 to 30 grams of whey isolate can provide 2.5 to 3 grams of leucine, making it an efficient way to meet the leucine threshold necessary to promote muscle protein synthesis in older individuals. In addition to its leucine content, whey protein is rapidly digested and absorbed, resulting in a quick rise in plasma amino acid levels and a more immediate stimulation of muscle-building pathways. This makes whey an excellent option post-exercise or between meals for those needing to meet protein goals without consuming large volumes of food. Eggs are another highly bioavailable protein source, with the egg white providing clean, low-fat protein and the yolk contributing essential nutrients and fats that support overall health. A large egg contains about 0.5 grams of leucine, meaning that 4 to 6 eggs can bring someone close to or over the leucine threshold when consumed in a single meal. Similarly, lean meats such as chicken breast and beef deliver high concentrations of leucine along with iron, zinc, and other micronutrients that support muscle function, oxygen transport, and immune health, all of which are essential for maintaining an active and resilient body as it ages. Cottage cheese and Greek yogurt are excellent choices for individuals seeking a slow, digesting protein source that also delivers a rich leucine payload. These dairy products contain casein, which digests more slowly than whey, providing a more sustained release of amino acids into the bloodstream. This makes them ideal for evening consumption, helping to maintain a positive protein balance overnight when the body is otherwise fasting. A cup of Greek yogurt can offer up to 20 grams of protein and close to 2 grams of leucine, depending on the brand and preparation. In contrast, most plant-based proteins such as lentils, quinoa, and legumes contain lower amounts of leucine per gram of protein and lack one or more essential amino acids. To match the anabolic potential of animal proteins, plant-based eaters must consume a greater total quantity of protein and often combine multiple sources to ensure a complete amino acid profile. Even then, it may be difficult to achieve the leucine threshold per meal without supplementation. This presents a challenge for older adults on plant-based diets, particularly if they have decreased appetite, digestive limitations, or restricted caloric intake. Contrary to the widespread belief that building muscle becomes nearly impossible after the age of 50, research consistently shows that the aging body retains a remarkable capacity to grow and strengthen muscle tissue when provided with the right inputs. These inputs include a combination of appropriate resistance training, sufficient high-quality protein, particularly leucine-rich sources, and lifestyle strategies that support hormonal balance, recovery, and inflammation control. Aging muscle is not biologically incapable of adaptation. Rather, it requires a stronger, more intentional signal to initiate the same processes that occur more easily in younger individuals. This means that growth is still entirely possible, but the approach must be more precise and grounded in evidence-based principles. Muscle tissue responds to mechanical loading, which means that resistance exercise remains a primary trigger for adaptation regardless of age. The key difference in older adults is that the stimulus must be consistent and progressive. When muscles are subjected to mechanical tension through strength training, they experience micro tears and stress that signal the body to initiate repair and hypertrophy. This biological response does not disappear with age. It becomes less efficient and requires reinforcement through consistent effort and proper recovery. Studies have demonstrated that older adults who engage in regular resistance training can gain significant amounts of strength and muscle mass, often reversing years of sedentary induced decline. To support this muscle building process, nutrition plays a foundational role. Protein intake must be elevated relative to body weight, and it must be spread evenly across the day to maximize the number of times muscle protein synthesis is triggered. More importantly, each feeding must meet or exceed the leucine threshold, generally around 2.5 to 3 grams per meal for those over 50, to activate the MTR pathway effectively. Without this signal, the repair and growth processes are blunted, leading to a net loss of muscle tissue over time. This is why quality matters more than quantity when it comes to protein sources in aging individuals. Beyond resistance training and protein intake, recovery and sleep are equally essential. Muscle growth occurs not during the workout itself, but during the rest and recovery phase. Deep sleep supports the release of growth hormone and other anabolic signals that promote tissue regeneration. Older adults often experience more fragmented sleep, which can interfere with these critical processes. Therefore, optimizing sleep through behavioral, nutritional, and environmental strategies becomes part of the muscle maintenance equation. Similarly, managing chronic stress and reducing systemic inflammation supports better muscle recovery and minimizes the catabolic processes that break down tissue. Hormonal support also plays a role. While natural declines in testosterone, estrogen, and growth hormone are normal with age, certain lifestyle interventions such as high-intensity interval training, strength training, and adequate fat intake can support healthier levels of these hormones. This internal hormonal environment, when optimized, works synergistically with nutrition and training to drive muscle growth and prevent further decline. Ultimately, the key takeaway is that muscle is a responsive tissue at any age, provided the proper conditions are met. The body retains plasticity well into later decades of life, and with consistent effort, even decades of muscle loss can be slowed, halted, or even reversed.